Hello guys, so in this video we have to find the double integral of this function where q is bounded by x is equal to under root of 4 minus y square and y axis. And here the hint is given in the question that we have to use the polar coordinate to solve the double integral. So first of all we will use some formulas to convert the Cartesian form of equation to polar form, like let x is equal to r cos theta, comma y is equal to r sin theta. Then if we will square and add both the terms x square plus y square, then it will become r square cos square theta plus r square sin square theta. Then if we will just take common r square, then sin square theta plus cos square theta will be 1. So this statement will prevail. And dA value in polar coordinates is r dr d theta. Now from this curve, first we have to draw this curve in the xy plane. Like if this is the y axis, this is the x axis, this is x axis, this is y axis, this will be a semicircle, but its value will be in the first and fourth quadrant. So this is the origin, this point is 0, 2, this point is 0, minus 2, and this point is 2, 0. So basically from here we can say that radius of the circle is 2, because the distance from here to here is 2 unit, and the angle varies from, that is, this is the angle, this whole is the angle. So angle varies from minus 90 degree to 90 degree. So radius varies from 0 to 2 and angle varies from minus pi by 2 to pi by 2. So now solving this double integral, we have to replace this pi by 2 is the constant, so we will take it as all together. This will be e to the power minus r square, and this will be r dr d theta. And what first we are solving for r, then theta, and theta limit will be from minus pi by 2 to pi by 2, and r limit from 0 to 2. So here pi by 2 will be thrown out of the integral. For d theta we will integrate separately, because there is no other term of theta in this integral, and we will solve e to the power minus r square multiply r dr and value from 0 to 2. So for this integral we have to substitute r square as t, then r dr will be dt upon 2, and if we will change for r is equal to 0, t is equal to 0, and for r is equal to 2, t will be r square, so it will be 2 square, it will be 4. So this is the change of limit. So by solving, so d theta integral will be theta, so integration from minus pi by 2 to pi by 2, and if we will integrate this from 0 to 4, e to the power minus t dt upon 2. So after solving this, this will become pi by 2 minus pi by 2, so this term will become pi, and pi by 2 is the constant. So pi by 2 is the constant here. This term will become pi, and it 1 by 2 again will be carried out from as a constant. This will be e to the power minus t upon minus 1, limit from 0 to 4. So pi square by 4, so value of double integral will be pi square by 4, and what e to the power, and minus sign will be also taken outside, so we can just write it in curly in bracket, so e to the power minus 4 minus e to the power 0. So what we can write it as, it will be 1 minus e to the power minus 4 into pi square divided by 4. So this is the value of the double integral. Here we have used the polar coordinate for the simplification of this problem, but we can also solve this problem by Cartesian coordinate form, but it will be a lengthier process. So here main thing what we have to remember is the angle, that theta is varied from minus 90 to 90. If this circle will be in this quadrant also, then theta will be from minus 90 to 180. So accordingly we have to see this. And if you want to ask such more doubts, please do mention in the comment box or visit my website www.doubtlet.com. Thank you very much.